I'm discussing chapter 2, that is sinusoidal steady state analysis. I'm starting lecture 3. In the previous session, with respect to sinusoidal steady state analysis, I discussed about what is average value, what is RMS value, then how to calculate average and RMS values of different types of waveforms. Before starting next concept with respect to sinusoidal steady state analysis, how to remember this note point to solve the problems. This also with respect to how to calculate average and RMS value. Yes. If any waveform is represented, any waveform is represented using Fourier series, as f of t equal to a naught plus a1 cos omega t plus pi plus a2 cos 2 omega t plus pi plus and so on. v1 sin omega t plus theta, this is pi 1, this is pi 2, plus b1 sin omega t plus theta 1 plus b2 sin 2 omega t plus theta 2 plus and so on. That is, either sine function is given or cosine function is given. This formula is applicable. Then how to find average value for this type of representation? Then average value equal to 1 by 2 pi, right? Integral 0 to 2 pi. This is f of omega t. This is the function in terms of omega t. Then you have to write this is f of omega t d omega. But every time integrating and substituting limits is lengthy procedure. That's why simply remember, for this type of representation, average value equal to a naught squares. The constant term indicates average value. Next, how to calculate RMS value? So RMS value equal to 1 by 2 pi integral 0 to 2 pi f of omega t square d omega t whole to the power of 1. But every time integrating and substituting limits is lengthy procedure. For this type of function, directly how to calculate RMS values. This formula is applicable. Either sine function is given or cosine function is given. This is a naught plus a1 by root 2 whole square plus a2 by root 2 whole square plus and so on plus b1 by root 2 whole square plus b1 by root 2 whole square plus b2 by root 2 whole square plus and so on. How to calculate RMS value? This is the formula for average value and this is the formula for RMS value. But where A1, A2, B1, B2 are the maximum values. That's why we are doing by root 2 to convert into RMS value. That is where A1, A2 and so on, B1, B2. All these are which values? Maximum values. If given is RMS values, don't do by root 2. Directly you can square that. A1, A2 and so on, B1, B2 are the maximum values. That is peak values. This is the maximum value. This is also maximum value. This is also maximum value. This is also maximum value. That's why I'm doing A1 by root 2, A2 by root 2, plus and so on, B1 by root 2, plus B2 by root 2, whole square. And one more point to remember, these formulas are applicable if frequency is multiples of frequency, omega, 2 omega, 3 omega, 5, like that, 4 omega, like that. Then only this formula is applicable. If equal frequencies are given, don't apply these formulas directly. Using phasor form, you have to simplify that. And finally, you can apply this one. That is, this is the note point, friends. Above calculations are applicable above calculations are applicable if frequencies are different. If frequencies are different. If frequencies are equal, don't apply this formula directly. For example, this is omega t, this is also omega t, this is also omega t, this is also omega t. Don't apply this formula directly. What you can do, first you have to simplify using phasor form, then you can apply this formula. That point you have to remember. That is, if any function is represented like this, or if any waveform is represented using Fourier series, then how to use these formulas to calculate average. Simply remember, constant indicate the average. Then in RMS value, DC term is present and AC term is also. If for example, this note also I am giving. In the above calculations, if A1 dash, comma A2 dash, and so on, B1 dash, B2 dash are RMS values, then how to calculate total RMS? Then total RMS equal to square root A1 dash, A2 dash, B1 dash, B2 dash are RMS values, and A0 is DC value. Then you have to write A0 square plus A1 dash square plus A2 dash square plus and so on B1 dash square plus B2 dash. Again, don't do by root 2. You have to square the direct. This is A1 dash square. Right, like this A1 dash square, and this is A2 dash square. If it is a peak values or maximum values, then only you do by root 2, then you can square. This one. That is B1 dash square plus B2 dash square, like this one. It's B1 dash square, this is B2 dash square. Clear? That you have to concentrate. And one more note you have to concentrate. See, for example, this note I am giving, that this is the sinusoidal function. Every observation is important, concentrate. So this is the sinusoidal function. This is the sine wave. This is the sine wave. This is the pi, and this is 2 pi. This is omega t. The maximum value is V, and this is minus V. This minus V. And it is a triangular waveform. That this is the triangular. This is the triangular waveform. That this is pi, and this is 2 pi. Writing on omega t axis. That this is Vm, and this is minus V. This is both are time varying waveforms. This is time varying, and this is also time varying. This is time varying. Time varying AC wave. That is sinusoid. This is also time varying AC wave. Time varying AC wave. This is also time varying AC wave. This is triangle. But we know that which waveform is used as a source? Which waveform is preferable as a AC source? Is a sine wave or a triangular wave? This is also time varying waveform. This is also time varying wave. But generally, I told already, the preferable AC source is sine wave, not triangular wave. Why you are preferring the sine wave is the AC source? The reasons I told already. Why to go for the sine wave as compared to other wave? What is the advantage of using sine wave? That is, every time varying wave is not AC source, but sine wave is AC source because it is an eigen function of LTI system. This is one more reason. It is an eigen function of LTI system. That is note I am writing. That is every time varying waveform. Time varying waveform is not a AC source. Is not a AC source. Is not a AC source. But sine wave is a AC source. Sine wave is a AC source because it is eigen function of LTI system. AC source because it is eigen function of LTI system. That is linear time invariant system. What do you mean by eigen function? Input function and output function is same. Then we can say that particular function is said to be eigenfunction of LTI system whose input and output is same, but phase may be different, amplitudes may be different. The function is same. When the particular waveform is said to be eigenfunction is input and output function is same. Function is same. Then we can say that that is eigenfunction. We know that I already told, take any linear time invariant system. For any linear time invariant system, LTI system, if input is a sin omega t plus theta, a sin omega t plus theta, what is the output? Output is also sine, but amplitude may be different. B sin omega t plus phi. That is, but if you give the triangular input to the linear time invariant system, but you don't expect same triangular function at output side. You don't expect same triangular function at output side. But in linear time invariant system, LTI system, linear time invariant system, linear time invariant system. If input is sine, output is also sine, but amplitude may be different, angle may be different. This is theta, this is phi. Angle may be different, but function is same. Because of this reason, sine wave is used as a AC source. Sine wave is used as a AC source. Every time varying waveform is not a at this point very constant. Next, one more important observation, friends. All these are the fundamentals with respect to AC analysis. All these are the fundamentals with respect to AC analysis. To simplify the calculations in the AC analysis, to simplify the calculations, or for easy analysis in AC, for easy analysis, we have to convert different parameters into frequency domain. We have to convert parameters into frequency domains. This observation is also important. Note, in AC analysis, in AC, for easy analysis, for easy analysis, we have to convert into frequency domain. We have to transform into frequency domain. That is, different parameters we have to transform into frequency domain. Then if it is transformed into frequency domain, then how it can act? Once it is transformed into frequency domain. See, for example, let's consider different elements. This is the element, time domain, Laplace domain, frequency domain, time domain, Laplace domain, and frequency domain. Let the resistance R. The resistance in time domain is R only. In Laplace domain also, it is represented R only. In frequency domain also, it is represented R. But actually, in frequency domain, we have to call this is acts as an impedance, but this impedance is R only. For resistance, impedance is also R. For resistance, the impedance is also R. That is, if you transform into, later I will give the definition for this. If you transform into frequency domain, it is R. It is taken as a R. That is, there is no change in the domain. The resistance remains same. If you take inductance, in time domain, inductance is L. In Laplace domain, this is important. In Laplace domain, the inductance is taken as a S into L. In frequency domain, replace S equal J omega. That is J omega L. This is J omega. This is in terms of ohms. This also in terms of ohms. J is the imaginary representation. Generally, we can use, instead of J, we can use I squares. That is I omega L. J omega L or I omega L. I stands for iota. But in electrical, the current is also represented by I. In imaginary, you studied the imaginary mathematics also. We have to use the I. But in electrical, current is also represented with I. To eliminate that confusion, instead of I, we are using J notation. Actually, we have to use I notation, imaginary. But why you are using instead of I, why you are using J? In electrical, current is also represented with I. There is some confusion. I stands for iota, that is imaginary representation. That's why instead of I, we are preferring the J. The reason that you have to remember. Why you are using J instead of I. Yes, friends. Then capacitance. In time domain, the capacitance is C only. This is 1 by Cs. In Laplace domain, it is a 1 by Cs. In frequency domain, replace S equal j omega. Frequency domain students, S equal j omega. How to write? 1 by j omega C. This is equal. This also represented in ohms. Like this, we can transform the time domain into frequency domain. The time domain into frequency. That is, see the observation here, friends. When inductor and capacitor brought into frequency domain, when inductor and capacitor is brought into frequency domain, then they start behaving as resistance. Because the units is ohms, this also ohms, this also ohms. It is behaving just like a resistance, which means they oppose the flow of AC current. Very important. See the observation. Why you are bringing into frequency domain in AC? For easy analysis purpose. Once you can bring this inductance and capacitance into the frequency domain, they act as a impedance or resistance, which opposes the current. That's why inductance and capacitance oppose the flow of AC current. The opposition offered by a network to the flow of AC current is termed as impedance. This is called impedance. How we are getting the term of impedance? Why this came into existence? Once we are transforming these elements into frequency domain, these elements acts as a resistance which opposes the AC current. The opposition offered by the network for the flow of AC current, the opposition offered by the network to the flow of AC current, that is called impedance. That term is called impedance. Now, here I am giving what is the definition of the impedance. The opposition offered by the network to the flow of AC current is called impedance. It is denoted by Z. But point to remember, students, impedance is a complex term. How to remember? Impedance is a complex term. Whatever the impedance we are using, that impedance is a complex term. Understand, students, why this impedance is coming? In AC, for easy analysis, we are transforming the elements into frequency domain. Once it is transformed into frequency domain, it acts as a resistance. Inductance and capacitance also just like a resistance. The units are ohms. Resistance means which opposes the AC current. The opposition for AC current is represented by impedance. Then impedance is a complex term. Impedance is a complex term. Then how to write impedance of inductance? How to write impedance of inductance? It is denoted by ZL, that is J omega L. We are transforming into frequency domain. These are impedances. Impedance of inductance is J omega. What is the impedance of capacitance? Impedance of capacitance. The impedance of capacitance. The impedance of capacitance is ZC, that is 1 by J omega C. The impedance of capacitance is 1 by J omega C. If you bring this J into the numerator, minus J by omega C. If you bring the J into numerator, J, multiply into J, divide with J. J square, J into J, J square. J square is minus 1. This we are getting minus J square. Like this, you can multiply into J, divide into J. Then J into J minus 1. That is minus J by omega C. That point. You have to use either I notation or J notation, but instead of I, you are using the J. The reason I told. What is the impedance of resistance? What is the impedance of resistance? The impedance of resistance, that is ZR equal to R only. There is no change of resistance, that is R only. If it is a RL is series, yes, and for series RL, then what is the impedance you have to write? R plus J omega. R impedance is R, L impedance is J omega. For series R systems, Z equal to R minus J by omega C. R minus J by omega C. This is R minus J by omega C. That is, impedance is a complex term. This is complex. Then what is the real part of Z? The real part of Z is the, which one? This is the real part of Z. The real part of Z is R. That is the resistance. This is the resistance. This is the real part of Z. The real part of impedance is resistance. The real part of impedance is resistance. And you know already, if impedances are in series, how you can write? If impedances are in parallel, how you can write? How to apply voltage division and current division? And I already explained. If you take the impedances are in series, for this I'm writing this. Students, I think you understood why this impedance term comes into the existence. Then how to define the impedance for resistor, inductor, capacitor. Why you are going for frequency domain in AC analysis. All these points will you have to answer. This, even in the explanation of series connection, parallel connection I given. If impedances are in series, if impedances are in series, if impedances in series connection, then what you have to write? Z equivalent equal to students Z1 plus Z2 plus. If impedances are in parallel, if impedances are in parallel, come on students, if impedances are in parallel, then you have to write 1 by Z equivalent equal to 1 by Z1 plus 1 by Z2 plus. The voltage division, current division of impedances are similar to resistance. The voltage division and current division of impedances similar to resistance. Similar to resistance. What are the method you are applied? Voltage division and current division for resistance. Same you have to apply for impedances. How to define what the reactance? How to define the reactance? What are the units of impedance? The impedance units is ohms. Impedance units. The impedance units is ohms. The impedance units is ohms. Yes. How to define reactance? It is defined for reactive elements, that is LNC. Reactance is defined for the reactive elements and it represents reaction of reactive elements when AC voltage is applied. What is the reaction of reactive elements when AC voltage is applied? Okay, that is nothing but a reactance. What are the units of reactance, friends? The units of reactance is ohm. Even reactance units is also. That is, reactance is the magnitude of impedance of reactive elements. Reactance is the magnitude of impedance of reactive elements. That is, reactance is the magnitude of impedance of reactive elements. Impedance of reactive. That is, reactance is defined only for inductor and capacitor, not for resistor. Magnitude of reactive elements. Impedance of, that is, say for L element, how to define reactance for L elements? What? That is ZL equal to J omega L. ZL equal to J omega L. You have to take the magnitude of this one. Magnitude of ZL equal to magnitude of J omega L. Magnitude of J omega L. This magnitude of J omega L is omega L. This is called XL. Then for inductive elements, the inductive reactance. This is called inductive reactance. What are the reactance is the magnitude of impedance. You find the magnitude of impedance of L. What is the impedance of L? Impedance of L is J omega L. No? For this, you find the magnitude, students. Magnitude is don't get imaginary. Then you can get omega L. Then this inductive reactance. This is called inductive reactance. XL equal to omega L. Omega is 2 pi F. That is 2 pi F L. You have to write the inductive reactance XL equal to omega L. That you have to write 2 pi F. What is omega L? Angular frequency in radian per second. Where omega is the angular frequency in radian per second. In radian per second. How to write capacitive reactance frequency in radian per second? How to write capacitive reactance? That is for C element. These are the reactive elements. For C element, what is the ZC? 1 by J omega C. Then how to get reactance? Take the magnitude of impedance. This magnitude of impedance is called which one? Reactance. Magnitude is don't take J, then 1 by omega C. This is called XC. Therefore, this is called capacitive reactance. Capacitive. This is called capacitor. Then what is Xc equal to? 1 by omega C. This is equal to 1 by 2 pi Fc. Understand, students, how the reactance term is coming? Step by step. If you transform elements into frequency domain, there is impedance concept. You find the magnitude of impedance, that's the reactance. But that reactance is defined for only for reactive elements, not for resistor. Then inductive reactance is omega L. Capacitive reactance is 1 by omega C. That is 1 by Fc. 1 by 2 pi Fc. Next, I define reactance, I define impedance. Then you have to concentrate admittance. 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 The admittance y equal to 1 by z. How to write? Admittance is equal to 1 by z. Y equal to 1 by z. Then what are the units? Inverse of impedance is nothing but admittance now. That is ohm inverse or mho. Ohm inverse or mho. Ohm inverse or you can also write Siemens or Siemens. These are the units of admittance. Then what is the admittance of inductive element? YL equal to 1 by ZL. What is the admittance of capacitive element? YC equal to 1 by ZC. YC equal to 1 by ZC. We know this. What is 1 by resistance, friends? G equal to 1 by resistance. This is called conductance. This is called conductance. R is opposition for current. What is the property of R? R opposition for current. Opposition for current, which opposes the current. Can anybody tell what is the G? If R is the opposition for current, what is the G, sir? If R is the opposition for current, what is the G? Come on, sir. Conductance is 1 by resistance now. R is opposing means inverse of R is conductance means property of allowing the current. Property of allowing the current. Can I tell like this? Property of allowing the current. Conductance is property of allowing the current because of inverse. Property of allowing the current. What is the Z? Property of opposing AC current. Property of opposing AC current. Opposing AC current. Property of opposing AC. But what is Y? Admittance. Admittance is 1 by impedance now. Property of allowing AC current. Property of allowing AC current. That is called admittance. Property of allowing AC current is the admittance. Then we have defined one more term here, susceptance. Susceptance. The susceptance is defined for reactive elements, just like inductor and capacitor. It is defined for reactive elements. Defined for the susceptance is defined for reactive elements. Defined for reactive. Then how to define susceptance of for inductor susceptance, inductive susceptance? BL equal to 1 by XL. For capacitive susceptance, BC equal to 1 by XC. BC equal to 1 by XC. Then what are the units of susceptance? This is ohm inverse, or mho, or Siemens, or Siemens. Admittance units is ohm inverse or mho or Siemens. But reactance units is ohms. What are the units of reactance? Ohms. What are the units of impedance? Impedance units is also ohms. Reactance units also ohms. But admittance units is mho. Even susceptance units is also mho. Then if you write a final conclusion, friends, resistance, inductance, capacitance, all these units are ohm. Then you have to write conductance 1 by resistance, admittance 1 by impedance, susceptance 1 by reactance. Then what are the units of these elements? Ohm inverse. Like this ohm inverse or mho or Siemens. This is about what the existence of impedance, reactance, and susceptance. Impedance, reactance, and susceptance. So R, that is ohm, R x Z. R Z x na, R Z x is ohms. G is 1 by R, Y is 1 by Z, P is 1 by X. That is ohm inverse or ohm mho or seconds. RZX is same, GYB units is same. Where G is the conductance, B is the susceptance, Y is admittance. R is resistance, Z is the impedance, X is reactance. This property indicates opposition for current or property of allowing the current. Property of this having the properties which one, sir? Property of opposition current. These elements are having the property of allowing the current. Property of allowing the current. So this is the concept of the impedance, resistance, reactance, admittance, susceptance, impedance. All these terms are exist. Now, before going to the in detail about AC analysis for different elements, how to write some basics of complex numbers. This knowledge is important to understand the different concepts of AC analysis. How to write some basics of complex numbers. Students, we know that. Let's consider impedance. We know that impedance is in complex representation. Let impedance Z equal to, you have to write X plus IY, but in electrical we are using X plus JY, where I is the iota. Instead of I, we are using J. Instead of I, we are using J, because in electrical current is also represented as I. To eliminate that confusion, we are using the J source. That is X plus J. This is a representation in complex form. This representation is the rectangular form. This is the rectangular form. This is rectangular form. You can also write in exponential form. In exponential form, this is Z equal to R into e power j theta. Z equal to R into e power j theta. This is in exponential form. Exponential form. You can also write R at angle of theta. What is this form, students? Polar form. R into e power j theta, R at angle of theta, that is in polar form. This we are using as for, what is R here? Magnitude of Z. Where R is the magnitude of Z. R is the magnitude of Z. That equal to square root x square plus y square. Theta is the angle, that is argument of Z. What is theta? Argument of Z. This is equal to tan inverse y by x. But this theta calculation depends on coordinate. In which coordinate it is operating? First coordinate, second coordinate, third coordinate. That is depends on quadrants, and direction of rotation. Is it clockwise or anti-clockwise? And clockwise and counterclockwise rotation. That is, it depends on quadrants and rotation. Direction of rotation. Direction of rotation of vector. How it is calculated, I will explain. These are fundamentals for AC analysis. The direction of rotation of the vector. It depends on quadrant. It also depends on direction of rotation. Students, you know that how you can write R into e power j theta, sir? R into e power j theta equal to, you write R into this e power j theta is cos theta plus j sin theta. This is according to which rule? This is as per Euler's identity. As per Euler's identity. As per Euler's identity, you write e power j theta equal to cos theta plus j sin theta. Cos theta plus. Then you can also write R cos theta plus j r sin. R cos theta plus j r sin. Now you see how to calculate the angles in different quadrants. Here I given calculation of theta depends on quadrants and direction of rotation of the vector. Quadrants and the direction of rotation of the vector. How it is calculated? That this is coordinate system. Please clearly understand this knowledge is also very important. Not only in network theory point of view, or other subjects point of view also. These are the fundamentals. That how to concentrate. That this is y, this is minus y, this is x, this is minus x. Let if the vector is represented like this is the vector representation, whose magnitude is r, angle is theta. Let this is in xy coordinates. XY coordinate system. This is the length in y direction. This is the length in x direction. Let this is modulus of y and this is modulus of x. Point to remember where x comma y is the number. Modulus x and modulus y is the length or distance. But in this is in first quadrant. This is in first quadrant. We know that in first quadrant, x is greater than 0, y is also greater than 0. X is greater than 0. Both are positive. X positive, y is also positive. In first quadrant, x is positive and y is also positive. X greater than 0, y greater than 0. Then how to calculate theta? Theta equal to tan inverse y by x. You have to take all are positive. This you take the positive values. Tan inverse y by x. Modulus x, modulus y is a distance. Xy is the number. Number may be positive or negative. But modulus length is always, distance is always positive. Distance is always positive. It never be negative. Understand? This modulus x, modulus y is, y taken this is distance. Distance never be negative, always positive. This is the theta. This theta directly you can calculate. This is how to calculate theta directly. Now, this is in first quadrant. Then how to calculate the angle theta? How to calculate the theta in second quadrant? Let this is the vector. This is the vector in second quadrant. So you have to take this is the vector in second. Just or take this is the vector in second. This also magnitude is r in xy coordinate. Then you can measure the angle like this. Now this is the theta 2. We are measuring theta. We are measuring theta angle. And this let this is the theta. This is theta. And this is y direction. This modulus of y. This is in x direction. Modulus of x. But in second quadrant, friends, in second quadrant, this is in second quadrant. X less than 0, y greater than 0. If x less than 0, y greater than 0, x less than 0, y greater than 0, then what is theta to you tell me? This angle theta. This total is 180 degrees now. This one. This total is 180 degrees. This is 180 degrees. In this 180 degrees, this is theta 2 students. This is you calculate theta. This is theta. From this total 180, you subtract theta. This total is 180 degrees. Sir. From total 180, you subtract theta. You can get theta 2 now. Then I am writing theta 2 equal to 180 minus theta. Correct? Or not? This total is 180 degrees. This angle total is 180 degrees now. This total 180. You subtract this theta, you get theta. Then 180 minus tan inverse y by x. Y x. These are the distance. How to calculate the angle in second quadrant? When you apply this angle calculation, x less than 0, y greater than 0. 180 minus tan inverse. Again, don't take these values are negative. This directly you take the positive values. Y and x you substitute here positive, don't substitute negative side. Why? X less than 0, y. These are distances. I taken already because of this negative, this is positive. This I already taken 180 minus. Then you substitute these values are positive values. Y and x is positive values. Modulus y, modulus x is always positive. This is theta 2 calculation. Theta 2 equal to 180 minus theta. Next is theta. Next we have to see one more vector here in third quadrant. This is in third. Let we are calculating theta 3. In third quadrant we are calculating. How to calculate the angles in different quadrants. Let the angle is calculated like this. This is the theta 3. This is the theta 3. This is theta 3. I'm calculating this is theta 3. Theta 3. Let this angle is theta. This is this total is 180 degrees. This total is 180 degrees. This total is 180 degrees. Then how to get theta 3? Theta 3 equal to 180 minus theta. From 180 you subtract the theta, we can get theta 3. From 180 you subtract the theta, we can get theta 3. But very important observation here that you have to concentrate. We are measuring this angle in clockwise. This angle is measured in anti-clockwise. I told already friends, if you measure the angle in clockwise, you have to take the negative. This angle is measured in clockwise direction. Clockwise angle measuring is, this is counterclockwise. This also counterclockwise. This also counterclockwise. Clockwise angle negative. Minus 180 minus theta. Minus 180 minus theta is tan inverse y by x. This is y direction. And this is x direction. This x direction distance is. That is, you have to substitute distance, not the value. Y by x. Understand? Why I taken this negative, multiply with negative? Angle is measuring in clockwise direction. Then minus 180 plus tan inverse y by x. But these values you have to substitute in. Substitute in. Which one? Magnitudes. Don't substitute, these are negative values. These are positive values. Then last angle is, this is in third quadrant. When you apply this angle calculation, both are negative. X less than 0, y less than 0, then only you apply this. Third quadrant calculation. In third quadrant, x less than 0, y less than 0. Then last one is in fourth quadrant, you have to calculate theta 4. I'm calculating, this is the vector. This x comma y, distance magnitude is r. This angle is theta 4. Then you calculate theta 4 equal to, here also angle is measured in clockwise now. If angle is measured in clockwise, you take negative. Tan inverse y by x direct. This from this point to this point only, na, theta 4. Tan inverse y by x. Modulus, you substitute is positive values. Modulus is always positive. This theta 4. This is fourth quadrant. When you apply this calculation, fourth quadrant x positive, x greater than 0, y negative, y less than 0. Then you apply this calculation. Minus, why taken minus? Because we are measuring in clockwise direction. If the angle is measured in clockwise direction, you have to take the negative. If the angle is measured in counterclockwise direction, you have to take the, this, I'm giving this note here. Separate. For clockwise CW, clockwise angle, clockwise angle is measured as negative. For counterclockwise or anti-clockwise, angle is measured as positive. Angle is measured as positive. See, for example, if it is like this, this is like this. This is Vm. Let the magnitude is Vm or V or V1. This is theta. Let this is theta. Let this is V2. This is theta. V1 theta 1, V2 theta. Then how you can write V1? You have to write V1 is, you have to write V1 at angle of, we are measuring angle this direction, counterclockwise direction, plus theta. How to write V2? V2 at angle of, we are measuring angle in clockwise direction, clockwise direction angle, counterclockwise direction. Clockwise direction angle is minus theta. This is positive angle. This is the, if angle is measured in clockwise, you have to take the clockwise and counterclockwise directions. And that, what are the summary I given? What are the formulas I given? I'm giving the summary here. First quadrant, x greater than 0, y greater than 0. Then what is theta? Tan inverse magnitude of y, magnitude of x. Next, second quadrant, Second quadrant. In first quadrant, always both are positive. Both are positive. Again, no need to take magnitude also. Directly you take y by x. First quadrant, na, we don't have any positive and negative. Then always positive. This is tan inverse y. Tan inverse y. Then second quadrant, x less than 0, y greater than 0. Then what is theta, students? 180 minus tan inverse modulus of y. All are positive only because these are the distances. Third quadrant. How we can measure the angle in third quadrant? Third quadrant, x less than 0, y less than 0. How we can calculate? This is theta 2, this is theta 3. 180 minus, sorry, minus of, you multiply the minus, na, minus 180 plus tan inverse y by x. Tan inverse y by x. But you substitute modulus. Then what about the fourth quadrant? How to calculate the angle in fourth quadrant? Fourth quadrant, x greater than 0, y less than 0. Theta 4 equal to minus tan inverse y by x. Minus tan inverse. But it is a modulus. All the values are positive only you take. Distances are taken as a positive. There is a calculation of angles in different quadrants. And one more point you have to remember. This I am giving out that I am giving. Concentrate. All these are the very important basics, not only for network theory point of view, for other subject analysis point of view also it is useful. How to calculate the angles. Please note down as a note. According to Euler's identity, according this studied even in mathematics also, according to Euler's identity. How to write? What is e power j theta? 1 at angle of theta. This is equal to cos theta plus j sin theta. Or write cos theta plus j sin. So for example, if z1 equal to r1 at angle of theta 1, z2 equal to r2 at angle of theta, r2 at angle of theta. Then how to write r z1 into z2? z1 into z2 equal to r1 into r2 at angle of theta 1 plus theta. That is in multiplication, angles are added. What is z1 by z2, students? What is z1 by z2? I'm not giving derivation, not required. r1 at angle of theta 1 by r2 at angle of theta 2. In division, angles are subtracted. r1 by r2, theta 1 at angle of theta 1 minus theta 2. r1 by r2 at angle of theta 1 minus theta. Next, if z equal to r at angle of theta, for the z power n equal to r power n, to write directly r power n at angle of n theta. So according to Euler's identity. What is the z power 1 by n? Z power 1 by n equal to r to the power of 1 by n at angle of theta by n. R to the power of 1 by n at angle of theta. Yes, if z equal to, you write like this, if z equal to a plus, if z equal to a plus jb, or outright z equal to a plus jb, then what is the z conjugate? Z conjugate equal to a minus j. What is the z into z conjugate? Z into z conjugate equal to a square plus b square. Z into z conjugate equals. What is z plus z conjugate? Z plus z conjugate. These two you have to add. Then 2a you can. Z plus z conjugate. Clear? That you have to ask. Any doubt? This is according to Euler's identity. Okay, students. So you have to see some questions based on this before going to the phasor representation. Can you try this? Come on, do it. Yes, friends, what is the answer for this? For this type of representation, how to find RMS value already given. Then you have to find VRMS. So VRMS equal to, first we check the frequencies. These frequencies are unequal. Then directly apply square root A naught square plus A1 by root 2 whole square plus A2 by root 2 whole square. Then what is the VRMS? Square root A naught 5 square plus 20 by root 2 whole square plus 10 by root 2 whole square. Then VRMS equal to square root 25 plus 20 by root 2 whole square, 400 by 2, 200 plus 100 by 250. Square root 275. What are the answers, friends? 25, 50, 400 by 2, 100 by 250, 270. Anybody? Come on, respond. What is your answer? I think you get 16.58 volts now. Right. 16.58 volts is next. The RMS value of the voltage V of t equal to 2 cos 3 theta, 4 root cos 3, 4 root cos 3t plus 45, 12 sin 3t is such. You have to find what the answer. What solution for this one? If you try to find the RMS value, VRMS equal to square root 2 by root 2 whole square, 4 root 2 by root 2 whole square plus 12 by root 2 whole square. This is wrong method. Don't do like this. Why? This formula is applicable if the frequencies are unequal. But here frequencies are equal. If equal frequencies are given, you have to convert into polar, you have to convert into phasor form. Frequencies are given. First convert into phasor form. Phasor form. That is in polar form. Phasor form, that is the polar form. Or you can also use coordinate, rectangular form, whatever may be phasor form. Then simplify, phasor form, simplify, then find RMS. This you have to apply. That's why directly don't apply that method. Then still I'm not explaining how to represent in phasor form. Later on we will see this problem. Later on, after discussing the phasor form, I will solve this question. Next. The average and RMS value of the voltage respectively. The average and RMS. You have to find what the average value of the RMS. What is the solution for this? V of t equal to 2 minus 3 into cos 100t whole square. Then first we simplify this. A minus b whole square. A square plus b square minus 2ab. 2 square plus 3 cos 100t whole square minus 2ab 3 cos 100. Then 4 plus 9 cos square 100t minus 12 cos 100. But the square term, you convert into normal form. 4 plus 9 cos square theta. How you can write? Cos square theta is 1 plus cos 2 theta by 2. Cos 2 into 100t by 2. Cos square theta equal to 1 plus cos square theta formula. 1 plus cos 2 theta by 2 cos square theta equal to 1 plus cos 2 theta na, by 2. Minus 12 cos 100. Simplify this. 4 plus 9 by 2 plus 9 by 2 into cos of 200t minus 12 cos 100. From this, what is V of t? V of t equal to 4 plus 9 by 2. No? So this is 8 plus 7, 8.5. This is 8 plus 9, 17. 17 by 2, 8.5. 4.5. First I am writing minus 12 cos 100t. Minus 12 cos 100t. 100t. Plus 4.5. 4.5 cos. Let us write like this. I am simplifying this one. Then I am writing V of t equal to say 8.5 minus 12 cos 100t plus 4.5 cos 200. Frequencies are unequal. Na? Directly apply this one. Frequencies are unequal. What is the average? Constant indicate the average. Average is equal to 8.5. Already given the formula. This indicates average. What is the RMS? RMS equal to square root. How to apply the formula? You know, RMS equal to square root 8.5 square plus 12 by root 2 whole square. Frequencies are unequal. This is 200 100 directly cannot. Plus 4.5 by root 2 whole square. Can anybody respond this? What is the answer? Plus 4.5 by root 2 whole square. Come on, students. What is your answer? 8.5 square plus 12 by root 2 whole square. See, don't apply this formula if their square terms is present. Convert the square terms into normal form. Cos square theta equal to 1 plus cos 2 theta by 2. 1 plus cos 2 theta. 2 into this we are getting how much? 12.4. Very good. This is 12.4. Then 8.5 is the average value. 12.4 is the RMS value. That is option B is the answer. This problem I will solve. After discussing phasor representation. After discussing phasor representation. Phasor representation. Because frequencies are equal, directly don't have. You have to try this. This is I1. If you want to solve this problem, also we have the knowledge of phasor representation. You have the knowledge of phasor representation. All these later on I will solve. The next session we continue. All these you have to solve. The next session. All these problems we continue. But this I am giving homework for you for practice. For the function shown in figure, find RMS value. All this homework. I already given some waveforms for RMS value. Later on, this I will solve session. Okay, thank you. This is about the today's session. Tomorrow session we continue. In the 8 o'clock, you have the SS subject. Any doubt? Okay, thank you. I'm ending the session.